Hi, this is group B39 and we will be introducing telescoping sums. I'm Juliana.
And I'm Pauline.
And I'm Zach, and I'm afraid of bright lights.
Telescoping sums.
Yay!
The definition of a telescoping sum is a series whose partial sums only have a fixed number of terms after cancellation.
Wow!
For example, if we have a sum of a k sub 1 minus a sub k, starting from k equals 0 and ending with n, we will have a sub 1 minus a sub 0 plus a sub 2 minus a sub 1 plus eventually a sub n minus a sub n minus 1 plus a sub n plus 1 minus a sub n, which will equal, after cancellation, a sub n plus 1 minus a sub 0.
Awesome!
For this example, a sub 1 cancels with negative a sub 1, a sub 2 with negative a sub 2,
Dot, dot, dot.
a sub n with negative a sub n, leaving a sub n plus 1 and negative a sub 0.
Okay, for our next example, we have the sum of 1 over 4n squared minus 1 from n equals to 1 to infinity. Okay, first we'll have to factor our denominator, and we'll get 1 over 2n plus 1 times 2n minus 1.
Wow!
By using partial fraction decomposition, we'll get a over 2n plus 1 plus b over 2n plus minus 1. Okay, the next step will be multiply both sides by 2n plus 1 times 2n minus 1. And we'll get 1 equals to a times 2n minus 1 plus b times 2n plus 1. Then we'll have to factor n out, and we'll get 1 equals to n times 2n plus 2b plus minus a plus b. From here, we can see that the coefficient of n is 0. So 0 plus 1 equals to n times 2a plus 2b plus minus a plus b. From here, we can say that 2a plus b equals to 0, and minus a plus b equals to 1. And b is equals to 1 plus a. And with this, we can substitute b in 2a equals to minus 2, 1 plus a. And eventually we'll get a equals to minus half. And b equals to minus half as well. From here, we know the constants value for a and b, and thus we can say that Sn equals to 1 over 2 times 2n minus 1 minus 1 over 2 times 2n plus 1. At n equals to 1, we can say that S1 equals to 1 over 2 minus 1 over 6. S2 equals to 1 over 6 minus 1 over 10. And S3 equals to 1 over 10 minus 1 over 14. With that, we can say that Sn equals to 1 over 2 minus 1 over 6 plus 1 over 6 minus 1 over 10 plus 1 over 10 minus 1 over 14 plus, eventually we'll get to 1 over 2 times 2n minus 1 minus 1 over 2 times 2n plus 1. We can notice that 1 over 6 will be cancelled with minus 1 over 6. 1 over 10 will be cancelled with minus 1 over 10. And eventually, we can conclude that Sn equals to half.
One of the practical applications to telescoping sums you may have noticed is, naturally, recursion, which is something everyone in computer science should be familiar with right around now. It is much easier to take the difference of the last and first result than it is to compute the actual sum, sequence by sequence by sequence of a large series. However, let us utilize more examples to help drive this home. Assume we have a sequence of numbers 5, 26, 43, 1,693, and 5. Now, let us assume that, for some inexplicable and probably malevolent reason, we want to calculate the difference of their sum. Thus, we shall utilize the telescoping sum, which would be the sum of n starting at 0 to 5, a sub n plus 1, minus a sub n, which would be equal to a sub n plus 1 minus a naught, which would also equal, in this sequence, 5 minus 5 equals 0. So you see how what would otherwise be an annoying, even if not impossible, calculation turns into a quick and fairly painless one. However, let's look at an example which is much less concrete and far more cumbersome and variable heavy. Let us take the equation, which is the sum from k equals 0 to n of the quantity k plus 1 cubed minus k cubed. Looks terribly frightening, right? And, well, it is. But once you kind of understand telescoping sums, it's not so bad. Let us begin writing this out and simplify as we begin to understand the pattern. 2 cubed minus 1 cubed plus 3 cubed minus 2 cubed plus dot plus the quantity n plus 1 cubed minus n cubed. Now you may have noticed the recurring pattern, but let's point it out anyway. Everything except the very first term and the very final term is being subtracted. Wow, that's awesome, you may say. And some of you might be saying, duh, that's obvious. But it helps everyone to see this sort of thing written out. Which gives us n plus 1 cubed minus 1 cubed, which can of course be simplified to n plus 1 cubed minus 1. And thus we have turned what would otherwise be a terrible, variable, ugly sum into something that's pretty easy once you figure out what n is.
Yay!
Woo!
This is group B39. Thanks for watching our video on telescoping sums.
I'm so afraid of